talk about volume and surface area of spheres today. We kind of just group them all in. The formulas are not so bad. For as far as vocab goes for spheres, all the vocab for spheres is the same as the vocab for circles. So things like a radius goes from the center of the sphere out to the outside. No matter where we put the radius in a sphere, it should be the same all the way around in every single direction. A chord goes from one part of the outside of the sphere to the other, just like in a circle. Does not necessarily go through the center. Then we have a diameter, which connects two opposite sides of the sphere together. It goes through the middle. And then lastly is a tangent, which is the same as a circle. A tangent touches the circle exactly once. All good on that vocab? Any questions? Same vocab as circles. Okay, so we do have two formulas that we're going to explore here. The first is the surface area of a sphere. I need us to imagine like a baseball. Has everybody seen a baseball before? You know, a baseball is made up of these two strips of leather that they basically just like put together like this, and they sew the seams together. If we take one of those pieces of leather and we spread it out flat, it would kind of take this shape right here, okay? We have to imagine that those two pieces on the ends of those pieces of leather, they're not quite full circles, okay? They all have this little extra piece that they would need to make full circles. So if we estimate that the piece that connects the two circles together fills in those two pieces, essentially what I'm saying is we're looking at, when I spread out that one piece of leather, I'm looking at about two circles. Does that make sense? Okay, it's a little under the correct area for those like end pieces, but it makes up for it because of the middle section. And I have two pieces of that leather. So really, if I have two pieces of that leather, and each piece of the leather represents about two circles, then the formula that I'm going to look at for the surface area of a sphere is 2 times 2 times the area of a circle, pi r squared. So the surface area of a sphere formula is 4 pi r squared. All good? That's about it for surface area. Okay, and then I'm going to talk about volume. Volume gets a little bit weird. When I see this picture, I don't know why, my brain immediately starts going to like a pineapple. Like I did literally Google pineapple earlier today because we were looking at these pictures. Like, you know how a pineapple's got all these little sections in it? Yeah, that's what I think about when I'm thinking about the volume of a sphere formula. If I were to take one of those sections out of my pineapple, it would basically look like a pyramid, essentially. Okay, how do we find the volume of a pyramid? The volume of one pyramid is 1/3 base times height for one pyramid, right? The height of each one of these little pyramids that makes up my sphere goes from the center of the sphere to the outside. That's a radius. So instead of height, we're going to use r for radius. And then I have a bunch of these little pyramids. So instead of just counting one of the bases of the pyramids and then multiplying it by however many pyramids, I'm going to calculate all of the bases of the pyramids together. So how do I find the area of the bases of all of those pyramids? Well, the bases of all of those pyramids make up the entire sphere. And we just found the surface area of a sphere formula. It's 4 pi r squared. So I'm going to take this formula that I just found for surface area of a sphere and plug it in for the bases. And then my formula looks a little bit like this. 1/3, the base is represented by 4 pi r squared, and the height is represented by r. If I now take that formula and I combine some things together, 1/3 times 4 is 4/3. I've got pi, and then r squared and r make r cubed. And that is the formula that we use for volume of a sphere. Any questions on those two formulas? So those two formulas are down here as well. So a nice little visual representation for us. The one key difference, like obviously the numbers in the front are different. Surface area uses a 4, volume uses a 4/3. But the most important difference that we need to keep in mind is that surface area uses radius squared, where volume uses radius cubed. Okay? The easiest way to remember this is to think about units. If you're thinking area or surface area, we know that our units are going to be like centimeters squared, inches squared, feet squared, something like that. And then we also know that when we talk about volume, we talk about units cubed. So centimeters cubed, inches cubed, feet cubed. That's how I remember what the radius is. If it's radius squared or is it radius cubed? Any questions on these formulas? Okay, flip it over. We're going to do one like this that is literally just a sphere. We're just going to practice using those formulas. My two formulas, my surface area formula is 4 pi radius squared. So I'm going to find the radius and I'm going to plug it in. That's the only thing I need in this formula. The radius is half of my diameter. So it's 11. So this is 4 pi times 11 squared. This is about the point where I stop caring about exact values. Like if you still find it in exact values, that's fine. But it's just so much easier to just plug this into your calculator. So I believe this is like 484 pi, but I wrote it down as 1,520.5 feet squared. Any questions? Okay. So then I do volume. Volume is 4/3 instead of a 4. Pi radius cubed. So I have 4/3 pi. My radius is still 11. And 11 cubed. 11 cubed, big number. I think it's 1,331 if I'm correct. But then times 4/3. There's no point in trying to figure out that in exact values. So just plug it into your calculator. I got 5,575.3. Keep in mind, our unit now needs to be cubed. I mean, that's essentially it for spheres. Is there any questions on like a basic sphere? Number 2. Does anybody know what we call this shape? It's got a fancy name. When I take a sphere and I cut it in half. It's definitely a word you know of. Any ideas? No. This is called a hemisphere. Right? We know like northern hemisphere, southern hemisphere. Same word. So this is a hemisphere. And we can get the formulas for finding surface area and volume of a hemisphere very easily, but they're also super easy to memorize. And it might be worth it to memorize them because we use hemispheres so often in homework and whatever. So might be worth it, might not be. I'm going to show you how we get to those formulas. So for surface area of a hemisphere, obviously it's a sphere that's cut in half. So I'm going to take my sphere formula, 4 pi r squared, and I'm going to divide it by 2. That gets me 2 pi r squared. And you would probably think, hey, that's it. That's all I need, 2 pi r squared. However, when I take a sphere and I cut it in half of my formula is going to get me the outside. But when I cut this sphere in half, I'm also exposing this whole section right here, which is a circle. So not only do I need half of the regular surface area of the sphere, but I also need to add on this circle here, which the area of a circle formula is pi r squared. So in total, the surface area of a hemisphere is 3 pi r squared. You can memorize that, or you can just find it like this every time. I guarantee you somebody's going to make the mistake of just cutting their hemisphere in half and calling it a day without remembering to add on that extra circle on it. So then I take my formula, 3 pi r squared, and I know that I know that the radius is 3. So 3 pi radius squared gets me, I believe, 27 pi, or if I wanted that in an approximate value, 84.8 centimeters squared. Any questions on that? That's the one thing we need to remember about surface area of a hemisphere. Volume of a hemisphere is much easier. I take my volume formula for a full sphere. Oops, I forgot a pi. 4/3 pi r cubed. I'm going to take that formula. I'm going to divide it by 2. If I take 4/3 and I divide it by 2, hopefully we know that that's 4/6, which simplifies to 2/3 pi r cubed. And that's our formula for volume of a hemisphere. We don't care that there's an extra base in there because volume doesn't care about those bases. So 2/3 pi, radius cubed. Well, 3 cubed is 27. 2/3 of 27 is 18 pi. 18 pi is about 56.5. And remember, our unit is centimeters cubed now. Any questions on that hemisphere? Useful formulas if you would like to have them memorized, but obviously we just found them pretty easily without having them memorized. Up to you what you want to do. Good. Are we ready for 2 composite figures? The composite figures are the big ones because I feel like we still struggle with these ones sometimes. So, we are finding surface area and volume of these composite figures. Let's start with the surface area. For the surface area of this figure, I have a sphere, well, 2 hemispheres, one on each end. 2 hemispheres make one full sphere. And then in the center, connecting the 2 of them, I have a cylinder. So I'm going to find one surface area of a sphere, which hopefully we know that that is 4 pi r squared, plus the surface area of my cylinder, but I cannot see the bases of this cylinder from the outside, so I want the surface area of the cylinder without bases. Anybody remember the formula for the surface area of a cylinder? The lateral area of a cylinder? Oh, it's been a minute. Check your blue sheets. That surface area of a cylinder formula is the perimeter times the height. The perimeter of the base is 2 pi r times h. Okay, so now all we got to do is plug stuff in. So 4 pi, the radius. Oh, I kind of covered over it. The radius of that sphere is 10. Hello. Plus 2 pi, the radius is 10. The height of that cylinder is 18. Plug it in to your calculator. 2,387 is what I have. All good? Let's do volume. Volume here is volume of my sphere plus volume of my cylinder. I don't care about the bases when I talk about volume, so I'm just going to add those pieces together. Excuse me. Volume of my sphere formula, 4/3 pi r cubed. Volume of my cylinder formula, it's on your blue sheets. It is area of the base times the height, which is pi r squared times h. Excuse me. So let's plug stuff in. 4/3 pi, the radius is 10 cubed, plus pi, radius is 10, squared times the height. Oh, excuse me. Plug it in. 9,843.7 centimeters cubed. Okay, I need water. You got it? What do we think?
To find like the volume of the box, you can find like the height through the diameters of the
Yeah, and then how are we going to find the empty space? What does that mean? Find the empty space. Caitlin?
You find the total volume of the box and then you subtract it from the volume of the spheres.
Yeah, we're going to take the volume of those spheres, we're going to find the volume of the box, and we're going to subtract the spheres from the box. That's essentially our overview. So let's start where Dahlia started here. We're going to find the volume of the box, which if you don't know what shape this is a rectangular prism. So the formula for a rectangular prism is area of the base times height. Well, this base is a square. So a 1.5 squared for our area of the base. And then just like Dahlia said, we're going to use the diameters of these spheres to help us find the height of this box. We know that one diameter of a sphere is 1.5. So if I stack 3 of them on top of each other, the height of this box is then 4.5. Everybody got that? I'm going to give you an estimate here. Well, actually, I think this is an exact value that I have written down. 10.125 inches cubed is the volume I got for that part of the box. And then I need to find the volume of the spheres. So there's 3 of them. I know the volume of one sphere is 4/3 pi radius cubed. Oops. I got to find the radius of this really quickly. So take your diameter, cut it in half. 0.75 is our radius. A little trick here. We know that if I multiply 4/3 times 3, those 3's are going to cancel out. So this is really like 4 pi radius cubed, which is going to come out to about 5.3 inches cubed. To find the volume of that empty space, I'm going to take this volume of the box and I'm going to subtract the volume of those 3 spheres to get about 4.8 inches cubed for that empty space. Any questions on that?